Greetings. My name is Omar Durder. FIU student is the project for EEL 4806. Now, the project will be on access denied. That's the title of the project. It will be discussing a brief introduction to a denial of service attack. I will be listing how they happen and ways to counterattack them. A denial of service or a DoS occurs when an attacker floods a network server with traffic, or the attacker sends several requests to the target server that then overloads it with traffic. Also, the server's requests are not legitimate and the return addresses are fabricated. Now, a DoS strategy is a strategy that is designed to keep valid traffic from accessing the target of the attack. Now, we will discuss the types of the denial of service attacks. They are the preventable attacks, the non-preventable attacks, flood-based attacks, software-based attacks, isolated attacks, and distributed attacks. I will go in further detail in the following slides. Now, a preventable DoS is sort of an honest mistake or a miscalculation. This occurs when a system admin is designing a network to perform many services without really understanding the limitations of that system that he created. Or now, an example of this is providing a service and miscalculating the percentage of usage, thus causing a denial of service attack. This is an unintended mistake on the part of the administrator that results in everyone using the limited resources that provide a denial of service scenario. It's not really an attack, it's sort of a miscalculation of the events. Now, a non-preventable denial of service attack is basically it occurs when the denial of service comes as a surprise that the system administrator is not really prepared for, any IT professional. An example of this is that a printer is not allowing others to print documents, but later realize that an employee in a prior shift has documents pending, thus holding up the traffic. The reason this may cause a problem is that the disk space is used up, which in turn denies other users access. In my own professional setting, I've actually had this exact problem where someone took a vacation, or yeah, they were on vacation and they printed a list and no one else was able to print out the list. I'm the one who ended up looking at who did this and found it was running up in the queue, and I had to end up getting a system admin, and I checked the admin names, and one person in my job was a system admin, and I had that person eliminate the task. Now we go to flood attacks, which is an actual attack, hence the name. It's not a mistake this time. This is when the attack consumes the limited resources of a computer or a network by transmitting a large number of packets as quickly as possible. The large number of connection requests being sent have a lot to do with this. The large quantity of bandwidth being consumed, the use of the victim's resources against them, and others using the resources of the victim against the victim themselves. So basically in this attack, someone using the actual victim's resources against them and flooding them with a bunch of requests and using up their bandwidth. So you would see it's a complete blockage of the system and no one really has access to it. Now we get to software attacks. A good reason of why everyone should be updating older software, OSs, Windows 10, regardless of what operating system someone may have, or patch up the system. This is why, because as we check Google Dorks, we found a lot of things that need to be patched up and that are not fixed, and people can exploit unupdated systems using software attacks. Now, getting to the software attack. What this does, it exploits existing software weaknesses, which in turn results in the victim's server crashing due to a degrading performance. Now, in general, the hackers generate a small or malformed packet in order to exploit known software bugs. We go back to Google Dorks and you could search this online, what are the stuff that are not fixed or what needs patching. This is the reason why. Now, this allows hackers to change or damage configuration files, which in turn hinders valid users and administrators from the normal use of the applications themselves. So update your systems. Now, an isolated attack or isolated attacks can be from anybody, hence the name isolated attacks. It can be from someone using a software, writing their own code, a bunch of script kiddies. Now, it can be obtained from a single source. Now, the most common way to stop this is kind of obvious at the firewall, whether it be the hardware firewall or the software firewall, uh, basically blocking traffic at ports on a switch. Now, this can be countered by blocking traffic from the source until the administrator of the domain can successfully fix the problem. Now, I won't get into too much detail of a distributed denial of service. I'm just laying out the basic fundamentals of a DoS, a basic denial of service attack, and what it comprises of. Now, a distributed attack or distributed denial of service attacks is associated with bots, botnets. Now, this attack does not come from one source, so this is more difficult to basically track and who is attacking you, and they will use spoofed IP addresses or computers. Now, the attack does not come from a single source. As we can see from the name distributed, this comes from multiple sources. It's often called, as I stated earlier, a distributed denial of service attack, DDoS, which uses multiple sources to conduct the attack. This allows attackers to control computers and forcing a large number of them to attack a specific host. So this person or persons, they will use multiple computers or bots, as we would call it, create a botnet and use all these bots to attack one computer. So you're not going to be doing anything. Your computer would crash and it would be terrible. You'd be using hundreds or thousands even. Now we'll be getting into known denial of service attacks. We're going to be into the specifics now. We have three of them here: TCP SYN, Smurf, and Fraggle. We'll discuss these in further detail. Now the TCP SYN, or SIN, this comes from the three-way handshake, as we all know: the SYN/ACK, and the ACK. Now, after the establishment of a TCP connection from both client and server, the three-way handshake takes place. After the attack takes place, once the server sends the SYN/ACK message back to the client, that is waiting for the response of the client. This is what we would call a halfway connection, in which the data structure contains only a finite size. Due to the excessive amount of half connections, this type of data structure in turn overflows the memory, resulting in a denial of service mode or attack. In a Smurf attack, the attackers use the ping command to broadcast ICMP request packets throughout a network. The ICMP echo request packets are sent to a computer in order to verify if the network is responding or not. If a computer responds as active, it will return ICMP echo request. Now, the packet amplifiers and computers on the network do not send the ICMP echo replies to the attacker's computer. The reason is because the attacker is using a spoofed address. So since it's a spoofed address, it's not going to go to his computer or her computer. The reply will go directly to the victim's computer, which they're spoofing, which is the origin supposedly of the pings. So it's not really the one pinging the request. This is the supposed one that the computer is seeing. Fraggle is very similar to Smurf attacks, that they basically use the same technique and everything. Now we'll get to the differences of it. The attacks are very similar, and use the same process and attacks. The difference between the Smurf and the Fraggle attacks is that Fraggle, instead of using ICMP, it uses UDP packets. The Fraggle uses a spoofed IP address in order to broadcast hundreds of UDP packets to the computer on the network. The intermediate device then sends hundreds of UDP echo reply packets to the victim computer. This will cause a system crash, the very most, that's what it will cause. The very least this will do is cause excess network traffic. In the following slides, I will discuss in great detail the prevention methods to use in a DoS attack. Now we'll go back to a proper switch selection. This is a very important technique to use. DoS attack prevention, firewall security, network address translation, and load balancing. These will be used in order to counter the attack. Firewall security is a great way of preventing a denial of service attack. You can either do it manually by selecting the ports that you want to use for incoming, outgoing traffic, such as if you have a server running on this port, you don't want it connecting with a server that a port that you use for regular surfing the internet or anything else you may deem, but that takes a long time. So this also provides regular firewall services. Now, this also provides high-speed access control lists that block selected content requests through the use of an IP address, TCP port, URL, or any type of file at all. Now, denial of service attack prevention is actually my favorite one of all of them that I've listed, in that it's a straight shooter and it's straight to the point and what you really want to do, which is preventing a denial of service. Now, this method is very efficient in all aspects so that it validates all the session flow at the time of the initial flow setup, which in turn eliminates all types of the connection-based denial of service attacks that you might encounter in the future. You block it from the get-go, so you'll be set from then on. This method is also effective in eliminating other abnormal or malicious connection types. My favorite part about this is that this prevention method does not have any impact on the performance at all of the switch. So this is in all aspects, this is a great method of prevention of a denial of service. Load balancing is also great to do in that it offers security for the server systems by providing the firewall load balancing. Now, this comes when selecting switches. So when you select switches, it is very important to select a proper switch that can detect and counter bottlenecks. So when you go shopping for a switch or setting up a network, this should be something to take into consideration. Get it done before you even set it up. You know what you're doing and set it up well. Firewall security is actually very critically important aspect to consider when dealing with traffic, because you stop it right there between the DMZ zone. So the way that this method eliminates initially a denial of service is by it abolishing single points of failure by distributing the traffic among multiple load balancing firewalls. Now, this is a more of a professional standpoint in a network address translation. You would have to know the specifics or get help from someone who knows the specifics, or if you know where traffic is coming from or a specific IP address that you don't want accessing your port. Now, the firewalls can stop specific IP addresses by using network address translation. The way that this technique prevents a denial of service attack is by refusing network traffic from a specific TCP port. So you would have to manually do this, manually configure it, understand what you're doing, because you don't want to do this to every IP address and you won't be able to even connect to the internet or get anyone connecting to your website or whatever. There will be no connection at all. So you will do your own denial of service if you don't know what you're doing. Now, this limits the network traffic coming from specific network addresses. This method also scans the network traffic for viruses or undesirable applications. That's why I said you have to know what you're doing in a network address translation. Mitigation is great. but it also has its downside. So if you're very professional and you understand what you're doing and you have years of experience, I would suggest mitigation. Now, a common tool that can be used to detect changes in the configuration information or other files is called tripwire. Now, the main issue, as I stated before, is the downfall that comes with mitigation is that attacks, if you don't know what you're looking for or you have no clue what's going on, the attacks can be mistaken very easily as just an increase or spike in the network traffic. So you have to understand what you're doing when running mitigation in here. You have to know what you're looking for. If you see an increase in traffic and it's not picking up anything, keep doing it manually and check what's going on. A great mitigation technique is to run an IDS system that alerts when the network is experiencing unusual traffic or activity. So this can also be used to any intrusion. You can detect Trojans or whatnot, but in this case we're doing denial of service attacks, so we'll be looking for that. Packet blocking from the origin IP address to the victim can also be done. This is the reference page. Basically, I just looked at the whole chapter 11 on denial of service attack, read the whole thing thoroughly, with my own knowledge, added my own twists to it. So this is my reference. I got it straight from the book and whatever knowledge I have based on this subject matter, which I enhance from the book as well. Thank you. This concludes the presentation.